In this mini clip, we will be solving trigonometric equations. While we answer this question together, you will be solving the similar problem on your own using the same technique. We are asked to solve for x, where the equation given to us is the square root of 2 times cos of 2x plus 1 equal to 2, and our x variable is bounded from 0 to 2 pi. To solve this question, we're going to begin by isolating for cos of 2x. I'm just going to rewrite our equation here. Isolating for cos of 2x, I'm going to bring this one to the other side of the equation. This will give us the square root of 2 times cos of 2x is equal to 2 minus 1. Now 2 minus 1 is simply 1. So our next line, I'm going to leave the left-hand side as is. But it will now equal 1. Simplifying this. Now we need to get rid of the square root 2. The operation here is multiplication, so I need to divide both sides of the equation by the square root of 2. Since division is the opposite operation of multiplication. These square root 2's will divide out to 1, and I'm left with cos of 2x is equal to 1 over the square root of 2. I will now like you to isolate for sine of 3x in the question that you were given. This is the answer you should have got. Coming back to our question, you'll realize that the trigonometric ratio for cos of 2x, 1 divided by the square root of 2, is positive. Let's determine which quadrant our angle 2x will be found in. Remembering our cast rule, C-A-S-T, the trigonometric ratio for a cos function is positive in quadrants 1 or in quadrant 4. This is because in our first quadrant, this A indicates that the trigonometric ratios for tan, sine, or cos are all positive. In the fourth quadrant, the C indicates that only the trigonometric ratio for the function cos will be positive. In quadrants 2 and 3, our trigonometric ratio for cos would be negative, which is why we're not going to consider these quadrants. This S means that only the trigonometric ratio for sine will be positive here, and in this quadrant, the trigonometric ratio for tan will be positive. So we're dealing with the first and fourth quadrant. I'm now going to draw the terminal arms in these quadrants. The theta represents the angle 2x. Now looking at our first quadrant right here, I'm going to draw a right angle triangle by connecting the end of the terminal arm to the x-axis. Because this is a right angle triangle, we are going to use SOHCAHTOA to help us solve our question. According to SOHCAHTOA, the trigonometric ratio for a cos function, the C here, is the adjacent over the hypotenuse. So here we have our trigonometric ratio for our cos function. I'm just going to put in brackets that this is really adjacent. I'm just going to write ADJ over the hypotenuse, HYP. Looking at a right angle triangle, cos of our angle would be equal to the adjacent, which is this side, over the hypotenuse, which is this side. We know our adjacent is equal to 1 according to our ratio, put a 1 here, and our hypotenuse is equal to the square root of 2. This triangle should now be familiar to you, since it is one of our special triangles. This other side will be 1, and the angles inside of our triangles will be pi over 4. So this is one of our special triangles that you should be familiar with. I would now like you to do this step with the question that you are given. In other words, I would like you to draw out your quadrant plane along with the appropriate triangle that's fully labeled. Here's the diagram that you should get. Coming back to our question, we realize that our theta, which went from here to here, is really equal to pi over 4. Theta, however, represented our angle of 2x. Therefore, we have that 2x is equal to pi over 4. This is our first angle. We need to solve for our second angle. Now we want to write out our principal angle. So we know this is our terminal arm of our second angle. So our principal angle will start here, will go around, and will end here at the terminal arm. Since we know that theta is pi over 4, so this angle here is also pi over 4. To solve for this angle outlined in red, we need to subtract pi over 4 from 2 pi, which is a complete circle. So again, 2 pi, which is a complete circle, minus pi over 4 will give us this angle outlined in red. This will actually give us an answer of 7 pi over 4. So this is our second angle. Lastly, we need to isolate for x, which means we need to get rid of this 2. To do that, we need to divide this side by 2, as well as the right-hand side of the equation, which means we need to divide both of these angles by 2. So our final answer, our x is equal to pi over 4 divided by 2 will give us pi over 8. 7 pi over 4 divided by 2 will give us 7 pi over 8. And this is our final answer. I would now like you to finish off the question that you were working on. And here's your final answer.